What's going on, my peeps? Actually, I have no idea why I went into an Italian mode right there. What's going on? But how's it going with you folks? Welcome to virtual class for our Algebra 2, and we are doing this on the day after, or the weekend after the hurricane. I hope that it wasn't too nuts for you. I don't mean to be sarcastic about that. I'm actually serious about hurricanes and whatnot. I told my kids, you really got to take these things seriously because hurricanes are no small thing. Are you guys all right? Is everyone all right? Does anyone live on the Big Island? Just making sure. Just want to know. Travis lives on the Big Island. Was it nuts? Was it like crazy? Your friend's roof blew off. That's crazy. Does anyone happen to live in Pune district? Because then we got a little election thing going on over there, and I know you guys aren't old enough to vote or anything, but I think it's going to be kind of interesting. I want to see what happens in that district for the next couple of days. Anyway, let's get this party started. Why don't we just start working on this stuff right now? I'm looking at... See, it's kind of hard to tell where we're on exactly, but I think this is where we're at right here. And we're talking about linear functions. So I've been talking about functions, and what we want to talk about right now is the slope of a line. The slope is actually, let's write it up over here, slope. The slope is defined as, how do you define the slope as? What do you guys think when you see slope? I think of two words that begin with an R and a fraction. Rise over run, exactly. Rise over run. Now this is actually an important concept. It means how far up you go divided by how far across you go. For example, if we were going to be making some stairs, we would actually have a certain code that we would follow that we would have to make these stairs at. And it would tell us how big of an angle those stairs are going. So we can kind of like put little markers over here, and then we would just kind of like connect those lines, and that would be our slope. Now, if it were a lot of rise and a very little run, that would look like this. A lot of rise, little run, a lot of rise, little run, a lot of rise, that kind of stuff. Actually, that's not a consistent stairs. Then your slope would actually be very angled like that, because there's a lot of rise and a little run. And I'll admit to you that because I am fat, that would be a very hard stairs for me to climb, because that means I would have to lift my leg up very high, and I would kind of have to balance on this small little ledge right here. I used to be able to do it when I was a rock climber, but now I've gained 60 pounds since I got married, so what are you going to do? But actually, this doesn't meet specifications for how you would be, what you would have to do. You can also have a very low slope, or I guess if you were actually building something, they could call that a grade. And you could have a low grade steps where it would be a little rise, big run, little rise, big run, little rise, big run. So you connect those dots. And that would be a line, and I described the slope, the high slope, as something that is very angled. Well, this one is kind of slightly angled. Does that make sense to you? Yes? No? Got it? Okay. All right. Now, we could have gone through and defined the slope as the run divided by the rise. We could have said, okay, well, your slope is actually a measurement of the run divided by the rise. And that would have actually worked out perfect if we told everyone in the world to change the system to be that way. So my question to you is, why did we choose rise over run? Why did we choose it to be rise over run as opposed to run over rise? If you don't know, say IDK, but I want you to chime in. I want to hear from you. Remember, we're developing a little culture where we're talking back and forth. So, IDK from Kaylin. What about you, Travis? IDK. All right, IDK. All right, you want to know my answer? My answer is IDK. I have no idea why they chose rise over run, but they did. It's now a convention. So, people, from now on, rise over run is the convention for slope. I guess it kind of makes sense, because if you think of something that is angled up very steep uphill, you would think, okay, that's great, I've got a bigger slope. But we could have gone through the whole world and said, hey, world, instead of calling it rise over run, we're going to call it run over rise. And as long as the world sits with that, then we're cool. Then we can start building our buildings and everything would be fine. But if you think about it like, or if I taught you that run over rise is equal to slope, that would work for our class until we start passing on our like construction things over to different builders, and they'll build it, and then they'll build like the backward system. And so anyway, it's rise over run, and that's kind of the key to this whole line business. Got it? So there's a few equations about lines. Do you guys remember any of the equations about lines that you're supposed to? I'm going to erase this. What are the equations you know about lines? There's one that starts with a y. Just this y equals mx plus b. Do you remember that one? Yes? No? Help me out here. Alright. What about m equals y2 minus y1 over x2 minus x1? Have you seen that one? Yeah? Alright, alright. And this is called the slope formula. This is called the slope-intercept form. This one right here is called the, I think it's called the point-slope form. It goes like this. Y minus y1 equals m times x minus x1. Have you seen that one before? I'm pretty sure that's the correct way of writing it. Yes. Now, you got a bunch of different equations. And when we taught this to you originally, we taught this to you as 3 separate equations. But really, it comes down to one concept. You can kind of nix this whole thing and just keep in mind that slope equals rise over run. I'll prove it to you. I'll show it to you. You guys ready? It's actually a really cool concept. And this is me showing you all of the, all of these equations. And all you got to do is understand that slope equals rise over run. Are we cool? You guys want to see it? Or are you guys like, nah, I'd rather just memorize equations. Don't show it to me. What do you want from me, folks? Yes, I want to see it. No, I don't want to see it. I need you to talk to me. It's a back and forth conversation here. All you gotta, I'm doing all the talking. All you got to do is write yes and no. There we go. Thank you, Alicia, for making sure that I'm not here by myself. All right, ready? The way I kind of think about this is I think this. If you have a graph, now draw this graph on a piece of paper, okay? Here's the x-axis, here's the y-axis. And we're going to go with 2 points. There's 2 points on this graph, and they're random points. They're not like actual, like 1, 2, which would graph at here. They're not actual points. They're just kind of vague points. So instead of calling it, like giving it an x coordinate and a y coordinate, I'm just going to call it an x and a y coordinate, but I'm going to put a little subscript 1 over here. Can you see that? Is that clear enough on the picture? I can erase it and redo it. I'm just waiting for you guys to talk to me. I'm a big fan of talking with people. What does it say? Kind of? Alright, here, let me do this. x1, y1. Is that better? Alright. Now, I'm going to choose another random point up here. And the coordinates for this, if this is point 1, this is going to be point, rhymes with shoe. What is it? It's point 2. There we go. So this will be x2, y2. And did I tell you the story about Taylor Lautner and Taylor Swift? I did, didn't I? Yeah, I did. All right, so you can understand the difference between the 1 and the 2. These aren't exponents; these are subscripts. So this, all it's saying is this is the x-coordinate that is tied to position 1, and this is the x-coordinate that is tied to the position 2. Just kind of like how Taylor Lautner will be TL and Taylor Swift will be TS, because this Taylor is the one that is associated with a person named Lautner, and this Taylor is the one associated with a person named S or Swift. We cool? So that's all those subscripts mean. They're not like an actual like separate function or equation that you need to do. Anyway, if I want to find the slope of this line, okay, I would need two pieces of information. I would need the rise divided by the run, right? I would need how high the thing goes divided by how far across it goes. So all we know about a line, and I'm telling you, all you really need to memorize is slope equals rise over run. If you understand this concept, you don't have to memorize any of these equations. You'll be able to derive them. Slope equals rise over run. All right. What it's doing is saying, all right, what's the rise? How high does it go up? If I start at height y1 and I end at height y2, how high did I go? Or maybe if all right, give me a yes, or give me the answer or IDK. Let me know now, and I'll give you if you don't know, I'll give you an analogy to kind of help this out. If I start at y1 and I go to y2, how high up did I go? Your answer. If you don't know, it's perfectly fine to say IDK. All right? All right. Okay. Let me make you think about this then. Say that we did have numbers, because I said I wasn't going to put numbers, but let's say we did. Let's say this point right here was 5 up here, and this point over here was 2 up down here. If I end at 5 and I start at 2, how high did I go? I'm talking about 5 feet high. I went 3 feet. How did you get that, Kaylin? I went 3 feet up. How did you figure that out? 5 minus 2, right? You get where you ended minus where you started. Agreed? Now let's take away the numbers and just think about the letters. Now, if I say I end at y2 and I start at y1, then how high did I go? Well, it's just where you ended. That's supposed to be a y, sorry. Minus where you started. Does that make sense? Now does it make sense? All right. Now, let's talk about, so that would give me this height right here. This height is y2 minus y1. Do you agree? Now the question is, how far did I run? How far across did I go now? Because that's my next part. I did the rise. I want to get the run. I want to figure out what the run is. I'll let you think about it. I'm going to give you some time. Go. Oh, come on. Don't say IDK just so early. Think about how I did the rise, and you figure out how I did the run. There we go. Who's that? Heavenly. Awesome. We got new people joining in on the class. I didn't even see you because I don't have the... I have the video popped up, but I don't have the other one popped up. All right, x2 minus x1, that's exactly it. Because I'm talking about, I'm ending at position x2, and I'm starting at position x1. Does that make sense to you, Kaylin? It's perfectly fine if you say IDK. I want you to say I don't know anytime you want, but if I think that you can get it, I'm going to push you a little bit more, all right? All right, so check this out. Look at this. We came up with this equation. You know what this equation says? It's really just slope, which is m, equals rise over run. That's what that equation, that's all that is. It's just a mathy way of saying slope equals rise over run, which is something for you to easy for you to memorize. So, see this equation? Look, it's the same one right here. Boom! Right there. That's all I needed. So I didn't need to memorize this equation. It's really just saying slope equals rise over run. It's a complicated way of saying it, and it's not even that complicated. If you think, okay, there's 2 points over here. Are we cool? Yes? Happy? Sad? Ugly? Well, don't admit to me if you're ugly. I don't see you, so I can't confirm or deny that, but I'm just saying. Is this good? We good? Awesome. Yeah, I should even stop saying "Are we cool?" because I mean that would imply that if you don't understand, then you're not cool, and that's not actually true either. So maybe, are you happy with this? Are you sad? Because I assume that if you don't understand, you're kind of sad with this. But anyway, let's go. All right. That's where that equation comes from. You want to know where this equation comes from? It's very simple. I'll show you. Take me a few seconds. You ready? What we're going to do is we have a point, the first point over here, and we have another point over here, x1, y1, and we have another point, x2, y2. And even though we don't have numbers associated with those points, like I don't have 1, 2, and 3, 5 as actual numbers that I can put in there, because they're variables. It depends on what 2 points you choose. They're still talking about 2 specific points. So what I'm going to do is I'm going to say the second point, you know what I'm going to do is I'm going to take, instead of saying x2, y2, I'm just going to make it x, y. And that just means it is a very general point that can be anywhere. Just go with me for that for just a second, all right? If it's a general point that can go anywhere, I'm just going to put, all I did was erase the 2's. Are we cool with that so far? Now, who's a big fan of fractions? Are you guys fans of fractions? If so, raise your hand. If you're not, actually, you know what? You can't really raise your hand. Well, I guess you could on mine, but you know what? Don't even raise your hand. If you're a big fan of fractions, say I am. And if you hate fractions, say I hate fractions. Come on, folks, chime in. I want to hear your voice. Kind of, sort of, not really like fractions. All right, fine. I don't like them. I don't like them either. I don't like them either. And that's my point that I was trying to make. So let's clear out these fractions. Let's take this fraction on the bottom. We'll multiply him up. Sound good to you? Sounds good to me because I hate fractions. All right. So I'm going to multiply both sides by x minus x1. So I'm going to multiply this m by x minus x1. And I'm going to multiply this right-hand side, this guy, by x minus x1. And that will kill that fraction, so I'll just have y minus y1. Did I make sense to you, or did I just talk crazy? All I did was I took this fraction part, this denominator, and put them up there. Multiplied both sides by the same thing. Come on, folks, chime in. Help me out. There we go. Heavenly says makes sense. Awesome. Oh my goodness. Look. There's another one of those silly equations. It really all comes from the same place. It comes from this concept right here, slope equals rise over run. We happy? We sad? We ugly? What's up? No, I should stop saying we ugly, because you guys aren't ugly. You're beautiful people, I swear, even though I've never seen you. Yay? Nay? Come on, help me out here. Got it. Awesome. Now, where does y equals mx plus b come from? Well, I'll tell you. It's actually pretty straightforward as well. Oh, darn. I dropped my pen. Oh, darn. I dropped my... I can't move in this small office like I have. Oh, sorry, excuse me, I dropped my pen. Alright, awesome. Alright, okay, wait, I'm going to do this, okay. Alright, I'll tell you where y equals b, mx plus b comes from. What's the best way to go about this? Alright. What I'm going to do is I'm going to solve for y all by itself. That's pretty simple to do because the only thing that's messing with the y all by itself is the minus y1. So I'm going to kick them over to that side and now have y equals m times x minus x1 plus y1. Everyone agreed? Everyone agree with me? All I did was I added y1 onto that side. Come on, agree, disagree. Alright. Okay, then all I did was I said, alright, I'm going to solve for y. I'm going to get y all by itself. So I have y. If I add y1 onto the other side, that's all I did. I just added y1 onto the other side. Does it make sense to you? Okay. Now all I'm going to do is I'm going to distribute this m into here because it's m and there's a parenthesis, so I'm going to distribute m in. So I'll have y equals mx minus mx1 plus y1. You got it? All I did was I distributed that m back into there. Yes, no, happy, sad? Alright. Now look, what they did was they said, alright, we're going to clump all of this together and call this b. So therefore we have y equals mx plus b. What is b? Well, technically it's m times x1 plus y1. Or it's y1 minus m times x1. That's technically what it is. Well, we're going to give it a name. We're going to call it this intercept, the y-intercept. It is where the line crosses the y-axis. And if I were to take this line, it would be right over here, b. What's the equation for b? Oh, well, it's that. But, I mean, don't worry about what that is. Just know that that's how we got it. That's how we got y equals mx plus b. So, look, I just proved to you these three equations. I derived it from a very simple concept. The simple concept was this. Slope equals rise over run. That's really all you need to really understand and remember and whatnot. You don't need to memorize every single one of these equations. I'll give you a hint. It's to your advantage to do so. But really the concept that I want you to take away from slope is slope equals rise over run. Let's move on because we're running out of time. Are we happy? We sad? Yes? No? Maybe? Questions, vomits, etc.? Awesome. Alright, so from Kaylin I got a okay. It's not a I'm happy, I'm good with that. It's alright. Alright, that's cool. That's cool. Anyway, let's move on. Let's see what is in store for us. Alright, there we go. I'm going to stop this recording.